All right, let's go ahead and get started. Just one more shot at explaining stuff. Question, yes? The course schedule is locked. Well, we'll see if we can fix that. How does the course schedule get locked? Let's see here. Modules. Course schedule. This thing right here, you guys can't see the Tuesday, Thursday course calendar? Really? All right, well, let's see if we can go fix that. All right. Publish. Edit. New page history. Edit. Let's see here. What's that now? The link is locked. Oh, okay. All right, the link is locked. Why would the link be locked? Okay. Oh, yeah, I probably know why. Okay. It's because I put it into something or other that's locked. Tell you what, I'll fix it later. All right, so, all right, I think I know what the problem is. It's the way Canvas is set up. If I put something inside something that can't be seen, even though I say you can see this one, you still can't see it. That's, okay, I'll fix that. All right, thank you for that. That's what I needed to know. All right, thank you. All right. All right, here we go. One more time. When is your homework due? Tomorrow before 3:30, because in Fretwell 121 we're having our standard review session, and I'll be going over it. Now, just to let you guys know, when you go over here to modules, or you can come over here to the upcoming homework and just click on it, it'll take you down here to the thing I set up for you guys, which is right here, test review. And you go and click on this thing. Now, as we open this thing up, here's the deal. Don't forget, when you're turning this thing in, you got to put your name and your section number. However, out of this entire document, what exactly are you turning in to me? Just the free response part 2 stuff. Not the part 1 stuff, just the part 2. From midway down, this is what you're turning in, because I want to see your work in terms of doing this particular material. Now, as I mentioned to you before, on this particular site, you have you can take the quiz and click on it. All I can do is preview it. So I can sit there and preview it. But what you're expected to do for the entire homework set, the multiple choice included, is I've actually programmed on Canvas the multiple choice answers. You just go in there and click on the answer. Remember, they're randomized, so even though it's A on question number 1, it may not be the first answer in your lineup here. But I also, because of getting you guys practicing on the free response part, I went ahead and multiple choice that stuff too, so you can actually do the whole thing and click on it and stuff like that. How many of you guys have done with this thing? Cool. All right. If you haven't, well, you got until 3:30 tomorrow, because at 3:30 it's due. But you're turning into myself, or more likely you're turning into Katrina, the part 2 only, stapled. Be neat, be organized, and show all details of your work and how you got the solution. Don't just put the answer in the blank and think you're going to get credit for that. Oh no, we're going to take off extra points for that. We got to see the work. What did you do to get this answer and stuff? Okay. All right. The other thing I wanted to tell you guys about was this. Now, what I did this time out is I've actually pushed back your test. Officially, you're supposed to have your test last Tuesday. But I decided to wait just a little bit to get this little soak-in time for all this material, especially for folks that added the class late and stuff like that. So the test is on Tuesday, obviously, but you've got to prepare for this thing. And look at this homework set as a great representative of what the test is going to look like. So I pushed it back a little bit just so you guys could have the soak-in time to get this thing down. But even though I pushed back the test basically 3/4 of a week here, what that doesn't mean that you're not responsible for this new material. We're covering this new material, even though it's not on the test. Section 2.3, which we'll finish up today, and I'm going to go on into Section 2.4. But if you look at Section 2.3, because I stated on the syllabus that it was going to be due, so 2.3, I believe, was due last class on the pre-section quiz, right? Watch the awesome video and take the quiz. But Section 2.4, I didn't know if I was going to get to or not. I'm not going to change this due date. So if you haven't done Section 2.4, well, that's okay. Catch a pattern. We're going to do it today, or at least a big part of it. But I'm going to leave that quiz open until February the 8th, which is I believe it's the Thursday, next Thursday after your test, so we can actually go over it. I'll finish up that material and then move on into Section 2.5. And I believe 2.5 I've also got due on that particular date as well. So I'm going to leave things the way they are. I'm not going to change any due dates. I know we're a little ahead on that particular, what I've designed on the schedule, but that's because we're just practicing on all these problems and stuff. So, all right, well, let's get started on today's lecture. All right, last time we were working on the short ways of doing the derivatives, because taking that limit as h approaches 0 of f of x plus h minus f of x all over h, it takes a long time to be able to get these particular problems done. So we are now discussing the short method on doing it because someone has called a pattern. All right, so I did a bunch of problems for you last time. I'm just practicing taking the derivatives the short way. But the last thing we finished up on was some of the physics stuff. So let's just rehash what we did here. And the idea. So the idea is this idea of position, velocity, and acceleration. And the big deal is this. The relationship between all three of these guys, position or distance, that you are based upon an equation here, is called S of t. We'll use this notation. The velocity of the particle, the velocity is change in distance over the change in time. And if you look at units, it would be something like feet per second or miles per hour or kilometers per hour. It is distance per time. And you hear that per in the units, you know it's a derivative. And the velocity, by definition, is the first derivative of position. And the acceleration, feet per second squared, meters per second squared, miles per hour squared, kilometers per hour, kilometers per minute squared. That squared means it's per, which means it's a second derivative. So acceleration is the second derivative of position, the first derivative of velocity. So, and again, we talked about doing this stuff last time about we gave you a particular function. We asked you what the velocity is. So you took the derivative. We asked you the acceleration function. We asked you, so that's the second derivative. We asked you the acceleration after 9 seconds. So you plugged in 9. And then we said find the acceleration when the velocity equals 0. This right here is where you're headed to, word problems. You want to find the acceleration. So I know I need to plug into the acceleration equation, which is based upon time, which means I got to figure out a time. We're supposed to figure out the time when the velocity equals 0. So I took the velocity equation, I set it equal to 0, but because they had no restrictions on time, I had to take a square root. And if they don't put a restriction on time, when you got to do a square root in a problem or any kind of even root, you got options of plus or minus. So I actually got two numbers here, plus or minus 4 seconds here. And when I plugged in 4 seconds, I then do 18 times 4, my acceleration equation. I got 72 feet per second squared, and when I plugged in negative 4, I got negative 72 feet per second squared. Now let's take this idea and let's get a little deeper into it. Okay? So again, what I'm discussing with you guys is something very important. Physics and the physical relationship between all this stuff. Now, most of you guys are probably taking physics this semester. If not, you've taken it in high school or whatever the case may be. But there's a huge relationship between the physics and the mathematics that we're doing here, especially here in calculus. So, a particle's position is described by the function S of t equals t cubed minus 9t squared plus 15t plus 10. T is measured in seconds, and S of t is measured in feet, so we know our units. We're supposed to find the velocity function. Well, no problem there. We know our physics. Velocity, by definition, is equal to what? The derivative of position. So let's practice our derivative rules again. What is derivative of t cubed minus 9t squared plus 15t plus 10? Well, derivative of t cubed is 3t squared minus derivative of 9t squared is 18t plus derivative of 15t is 15 and derivative of 10 is 0. Part B. Again, these are word problems. What's the velocity after 3 seconds? Well, what am I going to do? Plug in 3. So v of 3, velocity at 3 seconds. This would be 3 times 3 squared minus 18 times 3 plus 15. And I'll use my handy dandy calculator for that. This will be 3 times 3 squared minus 18 times 3 plus 15. And I got negative 12. Negative 12 what? What would the units be for velocity? Distance is measured in feet. Time is measured in seconds. So what would it be? Feet per second. Now, a velocity is a vector. And with a vector, when you guys get into Calc 3, we'll discuss more of this with you. But a vector has 2 components, what we call magnitude and direction. The magnitude of the velocity typically is referred to as speed. It is the numerical value. This thing is going 12 feet per second. But it is a velocity because it also has direction. The negative is telling me the direction that you're going. Now I have to put my orientation. So negative, typically the way we would do this stuff, is negative is either down or to the left. Positive is to the right or up, depending on if you're going up or down or right or left. Left is always considered negative, right is considered positive, up is considered positive, down is considered negative. So I can tell you, based upon this particular particle and the position equation that we're given, that at 3 seconds, this particle is moving 12 feet per second to the left or down, depending on the orientation. Does that make sense? Questions? Now, continue on. Here come some physics words. When is the particle at rest? What does it mean for the particle to be at rest? To be at rest, the particle is stopped. What does it mean to stop? It means the velocity is equal to 0. That's what stop means. Okay? When you hear the word stop, the velocity is equal to 0. So I'm going to take my velocity equation, which is 3t squared minus 18t plus 15. I'm going to set it equal to 0 and I'm going to solve. How am I going to solve this thing? Well, first thing I'm going to do here is factor. What do you got in common on this, the 3t squared minus 18t plus 15? You got 3 that's in common. You can factor that out. That'll leave you with t squared minus 6t plus 5. Now, leaving the 3 out, I think the t squared minus 6t plus 5 is going to factor. T squared is t times t. What times what is 5? That adds up to be 6. 5 and 1, I believe, is 5. And this, because the sign is plus, that means they're going to have the same sign. Since the middle term is negative, they're both going to have negative signs. Again, you set it equal to 0, and you solve by setting each factor that has a t in it equal to 0. So I'm going to set t minus 5 equals 0, and t minus 1 equals 0, and I get the answer t equals 5 seconds, and t equals 1 second. Those are the 2 times where the particle is at rest. The particle stopped. Does that make sense? Did I lose you guys anywhere? Again, we're playing physics on word problems. When they ask you when does a particle stop, you figure that out by taking the velocity and setting equals 0. That makes you stop when you have no velocity. When is the particle moving in a positive direction? Physics. When is a particle moving in a positive direction? When we talk about the particle moving, again, we're referring to the velocity. In a positive direction, they didn't specify here, but it's either going to be up or to the right. So what we're talking about here, for a particle to be moving in a positive direction, that means the velocity v of t must be strictly greater than 0. And we're going to solve for time. Now, this is going to go back to some old high school stuff that you guys have done, and that is this. The velocity equation, which was 3t squared minus 18t plus 15, we're going to solve it for when it's greater than 0. How do you solve a quadratic inequality is the big deal here. Well, the first thing you do is you treat the quadratic inequality as an equality. Set it equal to 0. And when I did that, I take the 3t squared minus 18t plus 15. When I set it equal to 0, I factored out the 3. That becomes t squared minus 6t plus 5 equal to 0. And then I factored it some more. That was what? T minus 5 times t minus 1 equals 0. And I solve and I get t equals 5 and t equals 1. I did all that good stuff up here. Just redoing it again, but here's the big idea. We're not trying to figure out when it's equal to 0. We're trying to figure out when it's moving in a positive direction. So we're really going to solve this equation. V of t is equal to 3t squared minus 18t plus 15 is greater than 0. How do you solve a quadratic inequality? You're going to draw a number line. You are going to put your, where it's equal to 0 time values on your number line. This is a velocity number line. And so we got here t equals 1. I'll make that t equals 1 and t equals 5. I got a question for you. Do you want to include 1 and 5 in your answer set is my question. Why not? Because it's strictly greater than 0. And right at 1 and right at 5, the velocity actually equals 0. It's stopped. They want it to know when it's moving in a positive direction. So 1 and 5, they're actually stopped. So I'm going to put little open circles on these guys because this is a strict greater than inequality. If it was greater than or equal to, if it had equal to on it, then I would want these guys in a usual filled-in circles. But now what you're going to do to solve a quadratic inequality is do test values. All right, here we go. Test value. Here's negative infinity all the way up to 1. Pick a number, use your brain, between negative infinity up to 1, and we're going to plug it into the velocity equation. Good choice. Time equals 0 is in here. And I'm going to do v of 0, the velocity at 0. That'll be 3 times 0 squared minus 18 times 0 plus 15. That's equal to 15. Don't care what the number is. What's the sign of it? It's positive. So this thing's moving positive 15 feet per second. But because it's positive, we know it's moving in a positive direction. Everything is moving in the positive direction in that time interval. All you got to do is just pick one test point and plug it and see if it's moving in a positive or negative direction. Same idea on the interval between 1 and 5. Pick a number between 1 and 5. I choose 2. Time equals 2. I'm going to do v of 2. This would be equal to 3 times 2 squared minus 18 times 2 plus 15. All right, 3 times 2 squared is 4, so that's 3 times 4, which is 12, minus 18 times 2 plus 15, and I get a negative 9 on my calculator. So this is equal to negative 9. Don't care what the number is. What's the sign of it? Negative. So in the interval between 1 and 5 seconds, I'm moving in a negative direction. That means I'm either moving left or I'm moving down, depending on my orientation. Now pick a number greater than 5 and do our test values. I choose 6. T equals 6. So v of 6 would be equal to, and just to save time here, this would be 3 times 6 squared minus 18 times 6 plus 15. And then just plugging it in, I get 15. I don't care what the number is. The fact that it's positive means everybody in that interval is positive. So to answer my question, When is the particle? When is a question of time. So when is the particle moving in a positive direction? Well, my time interval, so the answer here is time would be equal to, in a positive direction would be from negative infinity up to 1, but we don't include 1 because at 1 we stopped, union, and the rest of the positive. So it's over here, no restriction on time, and it's over here. And that would be from 5 to infinity. Those are the times that the particle is actually moving in a positive direction, moving to the right or moving up. Hopefully, this didn't come as a huge surprise. Solving quadratic inequalities, you got to do the test values and the number line bit on it. That's how we did it before. E is going to ask you something a little more difficult. When is the particle slowing down? All right. These are the words I want you guys to analyze from a physics perspective. Slowing down. How does a particle slow down? Let's talk about an example. Your car. You're driving down the road. Okay, you're on 485. You're driving on 485 at a whopping 75 miles per hour. Okay? And then you need to speed up. What do? You hit the accelerator and you go faster. So what exactly are you doing when you speed up? I've got my velocity and my acceleration are in the same direction. If I'm going, from Charlotte to Concord at 75 miles per hour, and I hit the accelerator and I crank it up to 80, 85, 90. Granted, blue light's behind me, but still, I'm cruising towards going towards Concord here. My velocity and my acceleration are in the same direction. That's when you speed up. Does that make sense? And vice versa, if I was leaving Concord and driving to Charlotte, same idea. I would be going, driving from Concord to Charlotte. I would be speeding up, hitting the accelerator, going towards Charlotte. The velocity and the acceleration are in the same direction. So to slow down, you're driving down the road, you're doing 75 miles per hour on a 70 zone, and when you see the highway patrolman sitting in the median, what do we all do? We hit the brakes. All right. We slow down. We hit the brakes and we slow down. And what slowing down is actually doing is we're accelerating in the opposite direction of which way we're headed. Does that make sense? So to slow down, the velocity and acceleration have to have opposite signs. Does that make sense? And this is the physics behind what we're talking about here. They're going to have opposite signs because, it depends on your orientation. If you want to consider, Charlotte negative and Concord positive, fine. If I'm driving towards Concord, that would be a positive direction. That would be my velocities going that way. But if I turn around and go from Concord back to Charlotte, that would be in a negative direction. Same idea with your acceleration. I got to accelerate in the opposite direction. So how am I going to solve this thing? Well, the first thing I'm going to do is I've already got the velocity information right here. And so I'll draw it again down here so we can compare. Here it is. Here's t equals 1. Here's t equals 5. Open circles on these guys right here. It was positive. That means I'm going at a positive velocity or to the right or up. I have a negative velocity, I'm going down or to the left, and then I'm back to positive velocity. So I've got the velocity equation. What I need is the acceleration equation. What is acceleration? What's the definition of acceleration? Second derivative. So this is s double prime of t. So the second derivative, the derivative of 3t squared minus 18t plus 15 is going to be what? 6t minus 18. Agreed? I'm going to set it equal to 0, and I would like to know when I have no acceleration. So this would be 6t minus 18 equals 0, 6t equals 18, divided by 6 on both sides, I get t equals 3. So at t equals 3, I have no acceleration. So I'm going to draw a number line over here. This is my acceleration number line. And on that number line, I'm going to put t equals 3, and I'll make it relative. Here's 1, here's 5. So t equals 3 is going to be right in the middle of this thing. Does that make sense? And I'm going to do a test value to see what direction am I accelerating in. Am I accelerating up or to the right or down and to the left? Okay? So use your brain. Pick a number that is less than 3. Good choice. 0. And the acceleration at 0 would be, remember your acceleration equation is 16t minus 18. So it's 6t minus 18. That'll be 6 times 0 minus 18. That's equal to negative 18, officially feet per second squared. But I don't care what the number is. What sign is it? Negative. So time intervals less than 3, I am actually accelerating in a negative direction. I'm accelerating towards the left or down. Does that make sense? Now, pick a number bigger than 3. That's right. I'm going to choose 4. 4, and I'm going to plug into my acceleration equation. Acceleration equation is, again, 6t minus 18, so this would be 6 times 4 minus 18. 6 times 4 is 24. 24 minus 18 is 6. I don't care what the number is. What's the sign of it? It's positive, which means I am accelerating in a positive direction. Does that make sense? But now, let's go and answer the question. When is the particle slowing down? As we discussed, the definition of slowing down is the velocity and the acceleration have got to be going in opposite directions. So as I use my little kind of pen here to kind of draw draw vertical lines over here at my time intervals. My time intervals are at 1 to 3 and at 5. Compare these two guys. Okay? So when are we talking about slowing down? So what about between negative infinity, again, slow down here, slowing down. They have opposite signs here, so I'm going to shade this stuff in right in here and right in here. That is from negative infinity up to 1. Between 1 and 3, they're the same sign. They're both negative. Between 3 and 5, velocity is negative, acceleration is positive, so that'll be union 3 to 5. So right in here, they have opposite signs. But over here, from 5 to infinity, I am the velocity is increasing and the acceleration is increasing. They're both in the positive direction, so they're not opposite signs. So the answer for slowing down is this. And remember, this is a time interval. It is between time is from negative infinity up to 1 and between 3 and 5 seconds. That's when the particle is actually slowing down. Does that make sense? Questions? Now, again, a lot of physics here, but once you think about it, it actually makes sense. The last one on this particular page is this problem here. Find the total distance traveled in the first 8 seconds. All right, distance. If you want distance, you have to use the position equation, S of t, and that was given to be t cubed minus 9t squared plus 15t plus 10. That was my original equation. We want to figure out the total distance. Now, to find total distance, here's the rule. You're going to have to subdivide when the particle is moving either to the right or up versus when the particle is moving down and to the left. Now we're talking about for the first 8 seconds, so our time interval here is between 0 and 8 seconds. Now, what direction is the particle moving? To figure out the direction the particle is moving, you look at the velocity equation. We still have it written up here. Okay? You can also look at it up here. Here's my velocity equation. between 0, again starting at 0 and we're going to 8. However, when I subdivide this, between 0 and 1, which way is the particle moving? Which way? Remember, positive is right or up, and negative is left or down. So between 0 and 1, I'm going to write it down here, between 0 and 1, this is moving in a positive direction. Does that make sense? Plus. What about between 1 and 5? What direction are we moving here? That's moving in a negative direction. I'm moving left or down because my velocity is negative there. And then picking up at 5, remember we're stopping at 8. So plus, from 5 to 8, we're moving back in a positive direction. These are my time intervals. Now, so to actually get the total distance here, this is what you're going to do. You need to know the distance that you covered in that first second, between 0 and 1. To calculate the distance you covered, the distance in this time interval would be s of 1 minus s of 0. And when I take s of 1 and subtract s of 0, do you know what kind of answer you're going to get? Well, what direction were you moving? In a positive direction, you're going to get a positive answer. Does that make sense? But I'm going to put absolute values around this so I can be consistent. So it still would be positive, but nevertheless, when in doubt, throw an absolute value around it. Because this is a distance. Distances are always positive. Plus, here we go. How do I calculate the distance between 1 and 5 seconds? Well, I calculate how far I've gone in 5 seconds minus how far I've gone in 1 second. This would be s of 5 minus s of 1. However, what direction am I moving between 1 and 5 seconds? Between 1 and 5 seconds over here is I'm moving in a negative direction. I don't want negative distances here, so I'm going to put absolute values around them so I want all my distances to be positive. And then the last one, how far did I travel going between 5 and 8 seconds? Well, once I pass 5 in the positive direction, so that would be s of 8 minus s of 5. It's already positive, but I'll just put absolute values around it so I can be consistent. Does that make sense? Questions? So now let's calculate that. Here we go. This is equal to absolute value s of 1. So I'm going to take this equation and plug in 1. 1 cubed minus 9 times 1 squared plus 15 times 1 plus 10. Notice when I plugged it in, I got 17. Minus when I plug in 0, I don't need a calculator to plug in 0. What am I going to get? 10. So officially, between 0 and 1 second, I've covered 7 feet. 17 minus 10, 7 feet. And it was in the positive direction. Plus absolute value. What is s of 5? So I'm going to go in here and take my equation, recall it back down again, and replace all those 1s with 5s. 5 cubed minus 9 times 5 squared plus 15 times 5 plus 10. I went negative 15 feet. Minus, what was s of 1 equal to? Well, we already calculated s of 1, and that was 17. And minus 15 minus 17 is a minus 32. So we actually went 32 feet in the left direction, but I don't want directions to worry me, so I'm going to take absolute value out. I went 32 feet. Plus, here we go, s of 8. Watch what I do here. S of 8, call this thing back down and plug in 8 for all my time. And I get 66 feet. So s of 8 would be 66 minus s of 5. But I've already calculated s of 5. What did I get there? Negative 15. But remember, I'm subtracting. Minus a negative makes it going to be even more positive. So this is equal to absolute value of 7 plus the absolute value of negative 32 plus the absolute value of 66. A minus a negative makes it plus 15 is 81. Absolute value of 7 is still 7. Absolute value of a negative 32 is what? Positive 32. And the absolute value of 81 is still 81. And 7 plus 32 plus 81 is 120. How much? Feet. Don't forget your units. That's how far I traveled. But you notice I had to subdivide my intervals based upon when I'm moving in a positive direction versus moving in a negative direction. And then I do absolute values around each one of those things and just add them up for total distance. Great physics problems to study. So here's some more examples off of WebWork here. Now what WebWork's going to try to do to you guys in section 2.3 is change the variables. The area of a disk with radius r is a of r equals pi r squared. Find the rate of change of the area of the disk with respect to its radius when r equals 5. Rate of change is another word we're going to start buzzing you guys on. Word problems. When I ask you to calculate the rate of change of something or other, we're asking you for the derivative. Rate of change means derivative. Okay? Rate of change of area. So we're going to take the derivative of area. As area is equal to pi r squared, pi is a constant, r is the variable, what would your derivative be? What is a prime, or for you Leibniz fans, dA over dr equal to? What's the derivative of pi r squared? 2 pi r. Now let's think about that from a physics perspective here, geometry perspective. Pi r squared is the formula for the area of a circle. When I took its derivative, what did you get? 2 pi r, which represents the circumference of the circle. There's a pattern. The derivative of area gives me the circumference of a circle. Does that make sense? Now, we're supposed to calculate this thing when r equals 5. So I'm going to put a little line there, and r equals 5. This will end up giving me 2 pi times 5, or what's my answer? What's 2 times 5? 10 pi. That's the rate of change of the area with respect to radius. 10 pi. Did I lose you guys anywhere? Rate of change means take derivative. Look at the next one. F of x is equal to 3/4 x to the 9th. Your mission, find f prime of x. Stole this off of WebWork. Now, right now, you guys, we haven't gone through what we call the chain rule property. All we got is those basic rules. And if you look at the basic rules, we don't have a bunch of parentheses around stuff with stuff on the inside, stuff on the outside of parentheses. So you know what you should do to any problem like this? John's fundamental rule of calculus. Clean it up first. So, because you have strict multiplication division here, f of x is going to be the same thing as 3 to the 9th times x to the 9th divided by 4 to the 9th. Strict multiplication division, powers can distribute. Cleaning it up, using my calculator, 3 to the 9th is an awful looking 19,683. X to the 9th divided by 4 to the 9th, 4 power 9 is 262,144. What is f prime of x? What's f prime of x? Well, first rule when you take derivatives, constants that are being multiplied by a variable, what do constants get to do? Hold over. So this is 19,683 divided by 262,144. Constant holds over. What's the root of x to the 9th? 9x to the 8th. So I can clean that up and multiply the 19,683 times 9, and I end up getting the answer 177,147 divided by 262,144. to the 8. Does that make sense? Clean him up first. Same idea on a problem like number 26. Now, WebWork likes me because I programmed it or whatever. So when I throw a problem on WebWork, man, it's awesome. Look at this thing. Square root of x times 3x plus what? Yeah, 0. That's great. Plus 0. You guys are not going to get plus 0. Only I get plus zeros on WebWork. So to make me feel better about your lives, I'm going to make that a 10 instead of a 0 so I can actually show you what to do because that looks more like your problem now. First things first, I don't do square roots. What's a square root? Half a power. So this is x to the 1/2 power times 3x plus 10. And now I'm going to distribute. I have yet to take a derivative. I'm just cleaning up the algebra. But when I multiply, I add exponents. So x to the 1/2 times 3x would be 3x to the 1/2 plus officially 1 is 1.5 or, let's see, 3/2. Plus, distributing the x to the 1/2 to the 10, that gives me 10x to the 1/2. So that's the trick. Always, any kind of derivative, you clean them up first. So now take its derivative. Once I distribute it, what's the derivative of 3x to the 9/2? I screwed that up. Excuse me. 3x to the 3/2, what's the derivative of that? Well, 3 times 3 is what? You can see where I'm going with my brain. 9 divided by 2, 9/2, x to the subtract 1. What's 3/2 minus 1? 1/2. Plus, what's the derivative of 10x to the 1/2? 1/2 of 10 is how much? 5x. Subtract 1 from the 1/2, you get negative 1/2. And there's my derivative. Now, right here is where people will screw this up because these are all 3-second questions. So I'm going to quiz you guys, see if you learned anything. On your mark, get set, go. What's the derivative of 12 pi squared? Oh, I hear it. 144 pi. Wrong. Here's the deal. Look at the function. What's it called? What's its name? F of x. What's the variable? No. What is the variable in this problem? X. The functional notation. F of x. X the variable. Where is there a variable in this problem? 12 pi squared. Just because it's got an exponent, don't let you make derivative by chunking it out front or whatever you do. Nope. Derivative is x. Do you see an x in this problem anywhere? No. I see a 12. I see a pi. 3.1415926 yada, yada, yada. Squared, which makes it, I don't know, 9 point something. Who knows? Some crappy 9 point something number times 12 is a crappy big number. And what's the derivative of a crappy big number? Is there's no variable in it. It's a trick question. 0. But what you guys just did is what most people do. We program you guys so well in taking these derivatives, you guys aren't even paying attention to where the variables are located at. That being said, I ask you now the question. F of x is equal to 12x squared. What's the derivative? Yeah, there is an x in this one, so then I get to bring down the exponent. What's the answer? 24x. And last but not least, what about if they threw this one at you? 12 pi x squared. What's the derivative? 24 pi. Because remember, 12 pi holds over. Derivative of x squared is 2x, and 2 times the 12 pi is a 24 pi times x. X to the first power. Does that make sense? Bring down the exponent, and then x to the subtract 1. 2 minus 1 is 1. More physics problems here. If a ball is thrown vertically upward from the roof of a 64-foot building with a velocity of 32 feet per second, its height after t seconds is given by the equation 64 plus 32t minus 16t squared. Part A, find the maximum height that the ball reaches. And part B, what is the velocity when the ball hits the ground? Again, great physics problems here. All right, so they gave me this. s of t, the position, which is 64 plus 32t minus 16t squared. Right? Question for you. What variable is this equation based upon? What is the independent variable? T. What does T represent? Time. So to be able to know anything about position, I have to know time first. Does that make sense? Well, we need them, so let's go ahead and use them. What is v of t? The velocity. Same thing as s prime of t. What would that be? Derivative of 64 being a constant 0. What's derivative of 32t? 32 minus, what is derivative of 16t squared? 32t. And just because I want to know, the acceleration is your second derivative. What is the derivative of the derivative? What's the derivative of 32 minus 32t? Negative 32. Derivative of 32 is 0. Derivative of minus 32t is a minus 32. Those are my pieces of the puzzle here. So now let's play physics. Understand the situation. We've got a 64-foot tall building. We've got some idiot standing on the top of this building, and he's throwing balls straight up into the air with an initial velocity of 32 feet per second. So he's launching these things off the building, straight up in the air. What's going to happen? These things are going to go up, slow down, and do what right here for just a second? It stops, okay? And then it comes down here and boom, hits somebody in the head. Right? We want to know what the maximum height the ball reaches. The maximum height is right here. Max height. But you said something just a few seconds ago. First off, to figure out the height, here is your height equation. You've got to figure out what the time is. But you said something a few seconds ago. When this idiot threw the ball off of the roof, straight up in the air, 32 feet per second, what's the ball immediately start to do? You throw a ball up there, what's it going to do? Immediately, due to gravity, the ball is going to slow down. Slow down. And then we talked about this point right here, and you even said the word. What happened? For just a moment right there. It stopped. It stops at the maximum height. To be stopping means you have a velocity equal to 0. So what was your velocity equation? It was what? What was it? 32 minus 32t. I'm going to set it equal to 0 for that stoppage. Okay, so it stopped there. And I get 32 equals 32t. I divide by 32 on both sides. And I get t equals 1. So when does the ball stop? After 1 second. But what we're interested in is the height at that 1 second. So what would the height be at that 1 second? So for that maximum height, you're going to do the original position, but you now know what the time is. What is it? 1 second. So this will be 64 plus 32 times 1 minus 16 times 1 squared. Well, 32 minus 1 times 32 is 32. 1 squared times 16 is still 16. 32 minus 16 is 16. And 16 plus 64 is 80. 80 feet. That's when the ball is at its maximum height. It's 80 feet above the ground. Does that make sense? What did you guys anywhere? Look at part B. When is the what is the velocity when the ball hits the ground? And try to give you a hint. Height is 0. So this ball came up here and threw it out and immediately started to slow down, slow down, slow down, slow down, slow down. Then it stopped. And now you notice that by the way, what's the acceleration due to the ball? When I throw a ball straight up in the air, what's its acceleration? Negative 32 feet per second or negative 9.8 feet per second, or meters per second squared. So it's either negative 32 feet per second squared or negative 9.8 feet per second squared. It's both negative. You know why? Gravity is pulling you down, downward direction. So it's always pulling you down. So So we launch this thing, but immediately it starts to slow down. For a moment it stops there, and then it comes back, and then goes down and hits somebody in the head. What is the velocity when the ball hits the ground? We want to know the impact velocity. What's the impact velocity? Well, velocity, not a problem, we're finding velocity. Velocity is equal to 32 minus 32t. So to be able to calculate any velocity, you got to know time. You tell me time, I tell you velocity. 1 second, the velocity is 0. 2 seconds, the velocity is negative 32. 3 seconds, the velocity is negative 64, so forth and so on. I plug in the number, that's what I get. Okay? So what I really need to do is when the ball hits the ground. When you hit ground, you are on the ground. Does that make sense? Which means your position is actually 0. You are on the ground. When you're on the ground, you have no height above the ground. So to figure out the time, I'm going to take this equation, which is 64 plus 32t minus 16t squared. I'm going to set it equal to 0. All right? Well, I could factor a negative 16 out of this thing. Let's see here. If I factor out a negative 16, I'm going to put it in the right order. This gives me a t squared minus 2t, because 2 times 16 is 32, and 64 divided by 16 is 4, and this is positive. Pull out a negative, that's negative 4. Equals 0. Does that make sense? You can divide both sides by negative 16 if you want to, and that gives you this, a smaller equation. T squared minus 2t minus 4 equals 0. How do you solve this thing? It's a quadratic. What would you like to do? It's a quadratic. What do you like to do to quadratics? Factor them. Knock yourself out. How does t squared minus 2t minus 4 factor? What times what is 4 that differs by 2? What times what is 4? 4 and 1 and 2 and 2. Which one differs by 2? None of them. It doesn't factor. Oh, of course. This is WebWork. Of course it's not going to factor. So I've got a quadratic that doesn't factor. How do I solve for t if I got a quadratic that doesn't factor? Quadratic formula. The old negative b plus or minus the square root of b squared minus 4ac all over 2a. In this problem, a is your leading coefficient, which is 1 because I divided by the negative, factor out negative 16. B is the coefficient in front of the t, which is negative 2. And c is your constant term, which is negative 4. Okay? So now I'm going to plug into this equation here. So t would be equal to negative 2 plus or minus the square root of b squared, negative 2 squared minus 4 times a, which is 1, times c, which is negative 4, all over 2 times a, which is 1. Okay? Crunch your numbers. T is equal to 2 plus or minus the square root of negative 2 quantity squared, which is 4. Negative 4 times 1 times a negative 4 is a plus 16 divided by 2. So t equals 2 plus or minus the square root of 20 divided by 2. You can clean them up if you want to. What times what is 20 that you can take a perfect square out of? 4. 4 times 5 is 20, and the square root of 4 is 2, so this is equal to 2 plus or minus 2 square roots of 5 over 2. And then take each term and divide by 2. And you see a bunch of 2's canceling here. But every time they cancel, you get 1. So it's 1 plus or minus the square root of 5. I got 2 answers. I got time equals 1 plus the square root of 5. And I got time equals 1 minus the square root of 5. Well, let's just check out what those guys are. 1 plus the square root of 5. I get 3.236. 3.236067977. So we're talking about 3 seconds here. And I got t equals 1 minus the square root of 5. negative 1.23. Negative 1.23, 606, 7977. However, in this problem, you got to make it relative. When we threw the ball off the roof, straight up to the air, that's when time started ticking. So if I got negative time, when would negative time be? That would be when the ball was being walked up through the building while he was going up there. Negative time is, in this example, is not going to happen. Because we're not talking about before he actually entered the building. We're talking about while he's on top of the building, that's when we started measuring it. So to get the velocity, this is your time. 3.23606 seconds here. So to get velocity, velocity at time equals, and I'll use the radical, 1 plus the square root of 5 would be 32 minus 32 times 1 plus the square root of 5. And who am I kidding myself? I'm going to go decimals on this thing. So this is 32 minus 32 times 1 plus the square root of 5. And I end up getting negative 71.55417,528. But it requires some units here, people. You got to give me units. It's physics. So it's negative 71.55 what? Feet per second. And what is the negative telling me? Direction. Which way is the ball going? Down, impacting the ground. So it's not a surprise. It's negative. 71.55 feet per second. Does that make sense? You guys understand? Let's talk physics here. So, it's going 71.55 feet per second. I don't think that registers to you people. So let me do this. I got the T84 and I'm going to hit my old apps button here. And I'm going to scroll down to scientific tools. And I'm going to do a unit converter. And this thing is feet per second. That's a velocity. So I'm going to number 6. I'm going to hit velocity. I'm going to type in my number. What was my number? It was negative 71.55417,528. What units was that? Feet per second. That one right there. I'm going to hit enter. You'll notice that because it's a calculator computer, it just basically turned E1, negative 7.1 E1 times 10 to the first. It took the scientific notation. But then what do we want to convert it to? Let's see something you guys understand. Miles per hour. My question to you is this. Look at this number and tell me how fast was the ball hitting the ground or somebody in the head or whatever it was doing. What was it? It is what now? Negative 4.8 E1. That means time 10 to the first, move the decimal place one place to the right. It was actually negative 48.7 miles per hour is how fast it was going when it hit the ground. Does that make sense? Yeah, it's going to hurt if it happened to hit somebody in the head. This is why when you go to places like New York or for that purpose, downtown Charlotte, you're not allowed to go on the top of skyscrapers and stuff like that and throw crap off the building. You know why? Because it's going to hurt. Because you draw it off the building and due to gravity, this thing, now we do have something called terminal velocity and things like that and air resistance and stuff like that. But if I take a baseball and just toss it over the side of a 400-foot skyscraper or something or other, yeah, that thing's going 120 miles an hour by the time it hits the ground. Okay? And it's going to hurt when it hits somebody. Right. And I've heard stories about throwing pennies off of the World Trade Center or the Empire State Building and stuff like that. And by the time it hits the ground, it'll actually shoot through somebody like a bullet. So again, you got the wind velocity, wind resistance and stuff like that. But don't throw stuff off buildings. It hurts people. Okay. Does that make sense though? Questions? All right. Section 2.4. I know. We're getting a little ahead of ourselves because we're supposed to do this after the test, but I got 15 minutes. This is awesome. Let's do some more work. Now, If you go back and remember, there were two things we talked about that we don't have a rule for like we do with adding and subtracting. And the concept is taking derivatives. When you take a derivative of things being added or subtracted, you take derivative of each one. But we do not have a rule until now for two things that are being multiplied. If you've got two functions that are being multiplied and you want to take its derivative, according to the rule, the derivative ends up becoming this. G prime of x times h of x plus g of x times h prime of x. Right out of your textbook. Or for you guys that love the Leibniz notation, the derivative of g function times h function with respect to x would be equal to the derivative of g with respect to x times h plus g times derivative of h with respect to x. But those are great. And memorizing those formulas, I guess, can be kind of helpful. But the words make all the difference in the world. Because we're going to get to some convoluted kind of problems later on. And remembering g times h, g prime times h plus g times h prime is not probably the way you're going to do it. You need to know the words. So the words are very simply this. When you're taking the derivative of a product, y equals g of x times f of x times g of x, then the derivative is going to be equal to, you take the derivative of the first, then you multiply it times the second, plus you multiply the first times the derivative of the second. Basically, you multiply, you do this alternating derivative thing. You take derivative of the first, and you multiply it times the second function, plus the first times derivative of the second. So you end up getting the derivative being equal to f prime times g plus f times g prime. And this is where they get their little formula from. So I did this problem for you guys in terms of the notes and stuff like that you're supposed to kind of read and watch through. So f of x is equal to 2x cubed plus 8x times 5x to the fourth plus 17. You're supposed to take derivative. This is a product, and I would take, because it's a product, I'm going to use what we call the product rule. And my goal here is to drum this stuff into your head so bad that even when you're 90 years old, you're going to be thinking back about the product rule, and the words in your head are going to be my voice. The derivative of the first times the second plus the first times the derivative of the second. So I'm going to keep repeating myself until everybody knows it. All right, so the derivative of the first. What's the derivative of 2x cubed plus 8x? Well, derivative of 2x cubed is what? 6x squared plus derivative of 8x is just 8. That's the derivative of the first. Then you do times the second. You just recopy the problem down. Plus, you take the first and recopy that function down. Then times the derivative of the second. The derivative of 5x to the fourth plus 17 is going to be 20x cubed plus 0. That's where the 20x cubed comes from. And this is your derivative. It's this alternating derivative thing. You take derivative of the first times the second plus the first, derivative of the first times the second plus the first times derivative of the second. You alternate the derivatives. Okay? So here's another classic one right here. See if you guys have these formulas memorized yet. If I want to take derivative of x times sine of x, you first pause and hesitate and ask yourself, what's the rule? X times sine of x. That times in the middle takes the product rule. So the product rule. So g prime of x would be equal to product rule. Derivative of the first times the second plus the first times derivative of the second. Derivative of the first. What's derivative of x? 1 times the second sine of x plus the first x times derivative of the second. Derivative of sine of x is cosine of x. And when you clean this up, 1 times sine of x is just sine of x. You get sine of x plus x cosine of x. And you'll notice that's exactly what I wrote here. Does that make sense? Now, honestly, if you had given me this problem on a test, you know what I would have done? John's fundamental calculus. I would have folded the darn thing out because it would be a lot easier to take derivative of, and then just take derivative of each terms. But you can't always do that, like with x times sine of x. I have to actually go this route with it. Okay? And I did a bunch of problems on the videos for you guys. Very simple. 7x squared times sine of x, product rule. X to the fourth plus the square root of x times 5x minus 1. Okay? So let's do these problems here and let's see if we can't practice it. The product rule. here we go. Now, as I mentioned to you guys, as well as for your homework set you're about to turn in, as well as the test and the notes and everything that we do, remember, this is calculus. Labeling is everything. This function is called f of x. It's equal to x to the fourth plus the square root of x times 5x minus 1. Well, the first thing you're going to do to this problem before you take a derivative is, before you take a derivative is, you're going to clean it up. I don't do square roots. So this is x to the fourth plus, what's the square root of x also known as? X to the 1/2 times 5x minus 1. Now, personally, this is one of those problems that I probably would have folded out and then take rid of each term. But since they gave it to me as a product, and this is called the product rule chapter, I'm going to take it using the product rule. Take derivative using product rule. All right, so product rule. Derivative the first times the second plus the first time derivative the second. Derivative the first. X to the fourth plus x to the 1/2. What's the derivative of that? What's the derivative of x to the fourth? 4x cubed plus, what's the derivative of x to the half? 1/2 x to the, subtract 1, negative 1/2. That is the derivative of the first. You take derivative of the first, product rule, times the second, just recopy the second, 5x minus 1. Plus the first, just recopy the first, x to the fourth plus x to the 1/2. But then you multiply times the derivative of the second. What's the derivative of 5x minus 1? 5. And there's my answer. And believe it or not, we're going to give you some directions in this section that you probably never heard of in calculus or any kind of math before. Take the derivative and don't clean it up. The reason why we're going to ask you not to clean it up in this section is this. When you write this thing out, we as the professors can grade this thing and can see what you're trying to do. This is the derivative of the first times the second plus the first times the derivative of the second. But once you start distributing the 5 and folding this thing out here and start combining like terms, I won't be able to see the product rule or the work that you actually did to get the answer. Does that make sense? So we're interested right now. Rest of chapter 2 is going to be working on derivative rules and a few application stuff. And because of that, we're going to ask you not to clean this stuff up. I also want to remind you, when it comes to your second test, the second test in Calculus 1 is the test where we're going to tell students no calculators. Because we're interested in your derivative taking skills. So we want to see the derivative things, not what your calculator can do for you, but what you can do for yourself. Okay, we want to see the rules. Which means if I am going to do word problems with words in it and numbers and stuff like that, I've got to reroute this thing and I got to make it simple such that, find the velocity when time equals 1. Great. So you can take derivative and plug in 1 and something real nice that you really don't need a calculator to plug into. All right. Look at the next guy. F of x is equal to x squared times cosine of x. Pause, hesitate, and ask yourself what rule? X squared times cosine of x. That's a product rule, so I'm going to use the product rule. Labeling is everything, so this function is called f of x. This derivative will be called f prime of x here. Product rule, derivative the first times the second plus the first time derivative the second. The first guy was the x squared. What's derivative of x squared? 2x. Derivative the first times the second cosine of x plus the first x squared. Let's see if you guys have been practicing. What's the derivative of the second? What's the derivative of cosine of x? Very good. Negative sine of x. It's a cofunction. Now, when it comes to simple arithmetic, simple cleaning it up, we're not talking about folding it out or distributing some ungodly something or other through a problem. No, I'm talking about if it's something simple like a constant or whatever, go ahead and distribute that through. Let's clean this guy up. What does it really look like? The answer is 2x times the cosine of x minus x squared times sine of x. By positive times a negative is a negative. I do that kind of cleanup. What I don't want you to do is like this problem up here and folding this mess out. Oh, no, we don't want to see that because that'll mess, but I'm trying to grade your work here. Let's see if you guys can do this one. What is the derivative of sine of x times cosine of x? Well, it's times, which means I'm going to use the product rule. Derivative the first times the second plus the first time derivative the second. What is the derivative of sine of x? That's my first function. What's the derivative of sine of x? Cosine of x. Derivative of the first times the second, cosine of x, plus the first, which is sine of x, times derivative of the second. What's the derivative of cosine of x? Negative sine of x. Of course, you want to clean it up. What is cosine of x times cosine of x? Cosine squared of x. What's a positive times a negative? Negative. What's sine of x times sine of x? Sine squared of x. And what is the cosine of squared of x minus the sine squared of x? No, that's plus. That's what I wanted to check. No. All right, let's go back and remember what we learned from high school. What is cosine squared x plus sine squared of x? Yeah, that's the Pythagorean identity. That's 1. What is 1 plus tangent squared x? Very good. Secant squared x. What is 1 plus cotangent squared x equal to? Check the pattern. Good, very good. Cosecant squared x. These are the 3 Pythagorean identities you guys are supposed to know. It's cosine squared x plus sine squared x that makes 1. What's that right there? Minus. I'm sorry. No, that'll work. That actually is a formula. I think that's the double angle formula for sine. So that's going to be what? Sine of 2x, if you remember your double angle formulas from trig class. But most of us don't. Only us math people do. So don't worry about it. We're not going to quiz you that hard on this stuff. But we do expect you to know this. And not tell me the answer is 1 because your sign was wrong because you've made a huge mistake there. Does that make sense? All right. Now, what I'm planning on doing in our first class after your test is I'm going to go back and look at these trig functions and I'm going to prove them to you. I'm going to prove the derivative of sine of x is cosine of x and also look at the proofs of the derivative changes of x, the secant squared of x, so forth and so on. I'm going to show you how these things work. But I want to go ahead and just mention this one to you guys before I let you guys go. Well, if you've got a product rule, you're going to have a quotient rule. Now, a quotient rule is this. A quotient, you've got a fraction. You've got g of x on top, you've got h of x on the bottom. What's the derivative? Well, according to the book, the derivative is g prime of x times h of x minus g of x times h prime of x divided by h of x squared. You got the Leibniz notation here. The derivative of g over h with respect to x is the derivative of g with respect to x times h minus g times derivative of, there's a typo here, derivative of, derivative of the bottom, h there, that's an h there, all over the bottom, h squared. Sorry, typo. I still find these things every time. All right. So, just like, remembering you got g prime times h minus g times h prime all over h squared. That gets a little old. Memorizing the words is going to be so much more important than than actually memorizing the formulas. Like the product rule. Derivative of the first times the second plus the first time derivative of the second. The quotient rule words is this. It's the derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. That's the real rules you got to have memorized because you know what we're going to do in the future. Our goal is to get you guys to have the ability to take really, really hard derivative functions. Really, really hard functions and take their derivatives. And they're going to be combinations of products with quotients, with a bunch of other things thrown into it, and you're going to have to take derivative of it. And you've got to basically figure out what's the big picture. If the big picture is a division, you got some crappy function divided by a crappy function, you need to take its derivative, it's the quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So I did this problem for you guys, and I kind of typed it up, but let's just look at it real quick. I got f of x is equal to 2x cubed plus 8x divided by 5x to the fourth plus 17. Clearly, it's a quotient. So what rule do I have to use? Quotient rule. We're math people. Don't think too deep in this. Quotient rule. Quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. You take derivative of the top. What's derivative of 2x cubed plus 8x? 6x squared plus 8. Drew the top times the bottom, you just recopied. 5x to the fourth plus 17. To drew the top times the bottom minus the top, which you just copied, 2x cubed plus 8x, times to drew the bottom. What's the derivative of 5x to the fourth plus 17? 20x cubed. But then you got all over, so long division here, all over the bottom, 5x to the fourth plus 17, the bottom function, squared. And that's where you get the rule. Drew the top times the bottom minus the top times drew the bottom, all over the bottom squared. Okay, and again, we're going to tell you guys, hey, please don't clean this up because we want to grade this type of thing. So we're going to have to actually get into your head these particular product rules and quotient rule problems because you're going to see in a little bit that we're going to start doing combination of these things. But first, you got to get through your test number 1. So make sure you get the homework set done and completed on Canvas. And remember, you're only turning in part 2 to Katrina. And then I will see you guys tomorrow at 3:30 and we'll go over the whole thing. See you guys then.